So throughout this video, you may need to be able to pause momentarily so that you have time to copy down the questions and then resume to look at the answers. So right now we want to look at how many different license plates are possible if A, we use digits and letters that are allowed to be repeated, and then also look at a separate option of what if the digits and letters cannot be repeated. And we want license plates that are 3 letters followed by 4 digits. Now to look at this solution, we have a 7-digit license plate. And the first thing we're going to look at is letter A. We're going to say, well, let's look at what this really means. That means that the first 3 digits, or the first 3 entries on the license plate, the first 3 are going to be digits. Right? The first 3 are going to be letters. First 3 will be letters, which means that we have, if we can repeat, we have the option of any letter in the alphabet. So all 26 letters are possible for each individual placement. That means I can have A, B, 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 whatever I want. Then the next 4 digits can be any number that I want, including 0. So I could, in fact, have A, 0, 0, 0, 0 as an option. And so if we multiply all of these possibilities for each entry on a license plate, we get this crazy large, over 175 million possibilities. Well, that's slightly different than what would happen if we do not allow letters and numbers to be repeated. So if we do not allow any repeats, that means the first digit, we have all 26 possibilities, but in the second position, now we no longer are allowed that one letter. So if I use an A here, I'm not allowed to use an A here, which means I only have 24 options. And then again, only 25 options. And then only 24 options. So you have to take one away every time you are at the next entry. Same thing with our digits. If I can have the option of all 10 first, then I only have 9 and then 8 and then 7 left, which gives me a little bit over 78 million options. Now, let's say that you need a 4-digit code is required to get into a facility. No digits can be repeated. I want to know what is the probability of a randomly assigned code with the digits 1, 2, 3, 4. And I do not care about the order. Well, let's look. Now we're talking about probability. And so the probability of this particular event happening. And so we can call that event A. Yep. Now, we need to go back to our permutation notation. That's a mouthful. And the total number of 4-digit combinations that we can choose from the 10 digits that are possible, this is going to give us the sample size. So this gives us the number of ways in a sample. And so you need to remember that when you are working with probability, probability is the number of favorable outcomes divided by the number of possible in the sample size. So our sample size here is only going to be 5,040 ways. Again, in a previous video, we talked about how to calculate this 10p4 by taking n factorial divided by n minus r factorial and expanding and simplifying in our calculator. So this is the number of total ways to get 4-digit codes. Now, something that you are going to need to know and have in your notes is what happens when you have a 0 factorial. Now, a 0 factorial is not 0. It's kind of a weird rule that in factorials, 0 and 1 both count as a single factor of 1. And so anytime you have 0 factorial, you're going to replace that with just the factor of 1. And anytime you have a 1 factorial, you will also replace that with the number 1. And you need that because you need to figure out what the number of favorable outcomes are going to be. And so in the possibilities of the 4-digit codes. I only want to know the number of favorite outcomes of the 4-digit codes selected from 4 digits. Now, that's going to be 24 different ways. Now, again, the reason why we are using 4P4 is that this is giving us only the possibilities of just 4-digit codes that are going to be out of the 10. But I need to know how many ways can I manipulate 1, 2, 3, 4. Because I can use, remember, 1, 2, 3, 4, 1, 3, 2, 4, 1, 2, 4, 3. There's a large number of possibilities, and those are going to be 24 options. So when I put that together in terms of probability, the probability of my event happening, the probability of the event where I am using the codes or the digits only 1, 2, 3, 4, is going to be the 24 options to get 4 digits out of the possible 5,400, so 5,040. So if I simplify that fraction, my probability is 1 out of 210. And this is going to be the process you're going to take for any of the probabilities dealing with permutations. Now for your final example, I want to know if a motorcycle license plate consists of 5 digits, again with no repeats, what is the probability of getting a plate with all even digits? Okay. And so here is how we're going to shortcut some of our information. We're going to set it up just like probability before. So again, the probability of the event happening that I am being asked about, so that is the probability that I'm going to be getting a plate with all even digits, is the number of favorable divided by the total possible. So now the number of favorable outcomes is going to be getting 5 of the 5. Okay, so again 5p5, and that's 5 factorial, which again is 5 times 4 times 3 times 2 times 1, or 120 ways. Now of the 10 different possibilities of digits, only 5 are even. So that's how I'm going to use the 10p5. Now in the denominator, okay, if I were to simplify down this fraction, again, sometimes you need to see a little bit more when you are working with the fraction in the denominator. But again, remember that's the same as 10 times 9 times 8 all the way down to 5 factorial, which we can cancel with the 1 in the bottom. And so this 10,9,876, when I multiply that out, gives me this 3,240. And the quotient of those two simplifies to 1 over 252.